Hi students, today we will talk about SSS, SAS, ASA, and HL postulates. Right now you're not sure what those are or what they are meant for, but we will discuss. So I want you guys to remember that this whole unit is about congruent triangles, okay? So just to kind of recap before we go into some new stuff, when we have two triangles that are congruent, so if I was to say that these two triangles are congruent, then that means their corresponding sides and angles are also congruent. So they have 1, 2, 3 pairs of corresponding sides that are congruent, and then they have 1, 2, 3 pairs of corresponding angles that are congruent. So there are 6 parts total on one triangle that are congruent to the corresponding 6 parts on the other triangle. So if you have all 6 of those parts that are congruent, then you can say the two triangles are congruent, right? What we're going to learn about today are some shortcuts where you can bypass knowing all 6 parts are congruent, where you don't have to know about all 6 parts to be able to say they're congruent. So we'll talk about that in a minute. But before we do that, there are some descriptions that we need to be aware of. So if we look at this picture over to the right, triangle ABC, AB has a relationship with angle C, right? We've talked about that before when we were talking about the triangle stuff last unit, but they are across from each other, or what we say it is opposite the other. Oop, opposite, yes, just make sure I'm spelling it correctly. Opposite. We can also say that angle A is opposite side BC. Angle A is opposite side BC. So segment AB is opposite angle C, and angle A is opposite segment BC. So if I was to draw an arrow from one to the other, I could see that it's across from this. Opposite means across. Okay. Then there's this other term which is totally new, and it's called included by. So let's go back to segment AB. Segment AB is kind of like in between angles A and B. So we say it is included by. Basically, they're kind of on either end, right? Kind of on either end. We can also say that angle A, right, is included by segments AB and segments AC because it's kind of right between those two segments, that angle. So we can also say that it is included by those two segments. So included by kind of means between, and opposite means across, okay? So make sure you know those because we're going to use those terms in a minute, and I want you to know what those mean. Okay, so the SSS, SAS, ASA, and HL, these are basically shortcuts, okay? So rather than knowing all 6 pairs of both sides and angles on both triangles are congruent, rather than knowing about all 6 of those, we can just know about certain segments and angles on the triangles being congruent. And as long as just those certain ones are congruent, that actually is enough information for us to conclude that the two triangles are congruent. But it's only in certain situations. So these are the situations. SSS stands for side, side, side. And it's exactly what it sounds like. If all 3 pairs of corresponding sides are congruent, then the two triangles are congruent. So if all I know is about the sides, I've got 1, 2, 3 pairs of congruent sides, and I don't know anything about the angles, that is actually enough information for me to say that those two triangles are congruent. Okay, so that's kind of like a shortcut. That's side, side, side. We just say SSS. Another one is called SAS, which stands for side, angle, side. Okay, and what that means, if two pairs of corresponding sides and the included angle, remember that means the angle kind of in between are congruent, then the two triangles are congruent. So let me explain what that means. You've got two pairs of congruent sides, and the angle between those two sides, or the angle formed by those two sides, is also congruent. Then just knowing that those three pieces of information is enough to say that the triangles are completely congruent without knowing anything about the other side lengths or angle measures. Okay, so that's SAS. That's another shortcut. The third shortcut is ASA, which stands for angle, side, angle. And what angle, side, angle means, it's saying if two pairs of corresponding angles and the included side are congruent, then the two triangles are congruent. So that means we've got two pairs of congruent angles, and the side between those angles, or the side that connects those two angles, is also congruent. Then without knowing anything else about my other two side lengths or my other angle measures, that is enough information to conclude that these two triangles are congruent. The last one is called HL, and this is specific to right triangles. So what the H stands for is hypotenuse. We might need to do a little refresher. And the L stands for leg. So real quick, off to the side, in a right triangle, the two sides that make the right triangle, those are called your legs. Okay, so this side and this side over here. The really long side that's across from the right angle, that's called the hypotenuse. So if you remember Pythagorean theorem, a squared plus b squared equals c squared, the hypotenuse is side C, and the legs are sides A and B. Okay? So you need to be able to recognize that. If this is new to you, please ask me a question if that's not making sense, because you need to understand that. Okay, so let's talk through this. So first of all, you have to have two right triangles, and you know you have two right triangles when you see that little box in the corner, or it says 90 degrees. If the hypotenuses are congruent, so remember those are those two long sides that are across from the right angle, side C, and one pair of legs, so just one of the other sides, are also congruent, then without knowing anything about the other two angle measures or the other side length, that is enough information to say that these two right triangles are congruent. Okay, so those are the four: side, 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 angle, hypotenuse, leg. But we just say SSS, SAS, ASA, and HL. All right, so let's try this with some examples. So for each of these examples, you have a picture, and you are using the information from the picture. So they're going to be given to you in markings, or sometimes in statements. First thing we're going to do is state all the congruent parts that we can see. Then we're going to decide how are the triangles congruent, meaning by SSS, SAS, ASA, or HL. So that is the justification based off the congruent parts. And then we're going to write that triangle congruent statement. And being able to do this process is really going to help us with our next lesson, which is when we actually formally write this in proofs. So we're kind of setting up for proofs, so this is really important to understand. So let's take a look at this first one. Looking at the picture, I see the things that are congruent. I see my arcs and tick marks. So the two segments that have the one tick, those are congruent. So that would be segment AB, or I could call it segment BA, put those two letters together with the line on top, is congruent to the other one tick segment on the other triangle, which is segment DE or ED. DE or ED. So what I want you guys to do, and I want you to get in the habit, since those are sides that are congruent, I want you to put a little S out to the side. And that'll help us when we get to part B, where we're trying to figure out if it's SSS, SAS, ASA, or HL. All right. So those are sides, so I put an S. We also see another pair of sides that are congruent with the two ticks. That would be side BC or CB, and that is congruent to side EF or FE. You can name it either way. And that is another pair of sides that are congruent. And then we also see the angles between those sides or included by those sides, angle B and angle E. Those are also congruent. Now, since that's a pair of angles that are congruent, I'm going to put an A. Okay. So let's take a look at what we have. We have two S's and an A. So by SAS, SAS, these two triangles are going to be congruent. Okay. And now we're going to write the congruent statement. So this is what we talked about last time. You put your triangle symbol. We're going to name one of the triangles. The first triangle you name, it doesn't matter with the order you put the vertices. So that first one, I'm just going to call it ABC. Now put your congruent symbol and the triangle symbol. When we write our other triangle's name, this is where we have to think about the position of the vertices. They need to correspond to the position of the vertices where I named my first triangle. So the A goes with the D, so I'm going to put D first. The B goes with the E, and the C goes with the F. And this one is easier to kind of figure out because the two triangles are oriented in the same way. This is an example of a translation where we just slid it over. Translation. And those are always nice because the triangle hasn't been turned or flipped, so it's easy to see which vertices go together. So that is what SAS looks like. All right, number 2, let's look at our picture. Let's see what we know from our picture. So I do see a pair of angles that are congruent. So I want to state that those are congruent. Now, they both have vertex P, but I can't call them both angle P because that's not specific enough because I have more than one angle at vertex P. So this is where I would have to name them using 3 letters, name these angles. So that first angle on the left, I can either call it SPR or RPS. Either one is fine. Just make sure that that middle letter is the vertex, and that is congruent to the other angle, which is we could either call RPQ or QPR. Angle RPQ. Note your notation. Make sure you're doing it correctly. P also should be in the center there. So the notation is very important. So this is a pair of angles, so I'm going to put an A off to the side, and that'll kind of help me when I'm determining which postulate describes their congruence. All right, I also, and sometimes this is a little bit hidden, but both segments share, both triangles share this segment PR. So PR on the left triangle is congruent to PR on the right triangle because they're the same segment. So it's congruent to itself. So we can say segment PR is congruent to segment PR. And that is a pair of sides. So I'm going to put an S off to the side. Okay. Now I also see those right angles. When two angles are both right, they're also congruent. You might also think, well, could this be an HL? Could this be the right triangles with the hypotenuse and the leg? Unfortunately, no, because here's my hypotenuses, but I don't know that they are congruent. So it's not going to be HL. So rather than saying that I have a right angle, we're going to just say that those right angles are congruent because we know that they are. Again, they both have vertex R, so we're going to name both angles with 3 letters. So the right angle on the left, I might call angle SRP or PRS. Either one is fine. Make sure R is in the middle, and that's congruent to the other right angle on the right triangle. We could call it angle PRQ or QRP. Again, we want to have that R in the middle. And that is a pair of angles that are congruent, so I'm going to put an A off to the side. So what we've got here, we've got a pair of angles, we've got the side between the 2 angles, and then another pair of angles. So that's angle, side, angle. The side is included by the 2 angles. So that's ASA. Now we're going to write our triangle congruent statement. And it appears that the triangle on the right has been flipped from the triangle on the left. So this is a reflection, and anytime you have a reflection, you have a line of symmetry somewhere, some line that it flipped over, okay? So that means, for example, this S flipped over to this Q, right? So for example, when I write my triangle congruent statement, I know that S has to go with Q. They have to be in the same position. So let's say I start with S for my triangle on the right. I could call it triangle SPR, SRP. Of course, I don't have to start with S. I could call it triangle PRS, RPS, whatever, right? So let's just put the other letters, maybe P and then R. So let's figure out what letters correspond to PR so we can name the triangle on the right. So P actually reflects back onto itself. So P goes with P, and R also reflects onto itself, so R goes with R. Because these 2 triangles share vertices P and R. So there is the congruent statement, and that is an example of ASA. All right, the one on the bottom, it looks, I immediately see these 1 ticks, so I know those 2 segments are congruent. So EH or HE on the left is congruent to FG or GF on the right. And that is a pair of sides, so I'm going to put an S. I also see another pair of sides that are congruent with the 2 ticks. Segment EF or FE on the top triangle is congruent to segment HG or GH on the bottom triangle. And that's another pair of sides that are congruent. So you got to look for that 3rd thing. Remember, there's 3 things you're looking for. Notice, just like in the last example, how both triangles shared PR. Both triangles here share segment HF. So it is congruent to itself. Segment HF or FH is congruent to segment HF or FH. And that's another pair of sides. So both triangles share those sides. So this time I've got SSS, which means these 2 triangles are congruent by SSS. So let's go ahead and write the triangle congruent statement. Let's name the triangle on the top first. The vertices are HEF. I can write its name with any combination of those letters in any order. I'm just going to go with HEF. So your congruent statement may look different than your neighbor's, but you need to make sure that the same letters correspond. So let's see, on the second triangle, the H actually is going to go, let's start with the E because that's a little more obvious. Notice how vertex E is between the 1 and 2 tick segments. Vertex G is also between the 1 and 2 tick segments. So E is going to go with G, so that middle letter needs to be G. Now here's the deal though. The triangle on the bottom, try to think how it was transformed. To me, it looks like it was rotated. This is a rotation, which means that H rotates over to F and F rotates over to H. So H goes with F and F goes with H. And that might be a little harder for you to understand, but if you turned your head upside down, you would see the bottom triangle looks just like the top triangle when your head's turned right side up. So this is an example of SSS. All right, let's do another one. In this triangle on 4, I immediately see this pair of angles that are congruent. Angle V is congruent to angle Z. I'm going to put an A off to the side because those are both angles. I also see these two segments that are congruent. So segment VX is congruent to segment XZ. And that's a pair of sides, so I'm going to put an S for sides. And then that's all I see initially, but if you look very closely, something we've learned, this angle and this angle are congruent because those are called vertical angles. And if you remember, vertical angles are congruent. So don't forget that. So because we have two angles that both share vertex X, we have to name them with 3 letters. So that angle X on the left we could call angle WXV or VXW. Choose one of those. And that's congruent to the angle X on the right, which we could call angle YXZ or ZXY. And that's a pair of angles that are congruent. So if I look at my letters, I've got ASA. Notice that the sides that are congruent are between the two angles that are congruent. So it's included by. So by ASA, these two triangles are congruent. Let's write the triangle congruent statement. For the triangle on the left, call it anything you want. WXV, VXW, XVW, doesn't matter. Just the 3 vertices. And then the triangle on the right, when we name that, that's when we have to kind of think about the order. So we have to think, how is one triangle transformed from the other? To me, it looks like they were reflected over this line. This looks like a reflection, which means the X, which is the same on both triangles, that's just going to reflect upon itself. The V reflects over to the Z, right? It goes over here. And then the W reflects over to the Y. So whenever I think of reflections, I think of like a volleyball game. The line of reflection is the net, and you're bouncy, or you're hitting one ball from one side of the net to the other side. All right, let's look at the one on the bottom. I see, let's see, we see the right angles. Now, before we say anything about the right angles, if it could be HL, let's see if the hypotenuses and the leg, one pair of legs, are congruent. So this pair of sides are congruent, and they're across from the right angle, which means those are the hypotenuses. Okay, I'm going to put a little H there to help us remember. So we can say that those two are congruent. We also can see that they share this side FR, so it's congruent to itself, and FR happens to be a leg. So we very well could use HL here. So let's go ahead and first say that those that we've got 2 right angles. So what you're going to do for HL, you're not going to say that the right angles are congruent. You're just going to state that you have 2 right angles. And because they both have vertex R, we're going to use 3 letters to name them. So the one on the left we could call angle FRY or YRF. So this one's not actually a congruent statement. I'm not going to have a congruent symbol. I'm actually going to just say that they're both right angles. The right angle R on the right we could call angle FRO or ORF. So you're going to say these 2 angles are right angles. That's all you have to say. So off to the side, I like to put an R for right angles, and that helps me remember that I have a right triangle and could use HL. All right, the 2 H's or hypotenuses that are congruent are YF, and that's congruent to FO. And I'm going to put an H off to the side. I know they're sides, but they're also hypotenuses. And then FR is congruent to itself because both triangles share that segment. And that happens to be a leg. So I'm going to put an L. So just because you have a right angle, like in this example over here on example 2, doesn't mean you're going to have HL. So you have to see if you have a hypotenuse and a leg that are congruent as well, which we do. So this time, these 2 triangles are congruent by HL. Okay? So let's write that triangle congruent statement. It does look like the triangles are also being reflected over that line. This is a reflection. So keep that in mind as you're writing your congruent statement. The triangle on the left, let's just call it triangle FRY, and it's congruent to the triangle on the right. But let's be mindful of the order that we put our letters. F on the left goes with F on the right because it reflects upon itself. Same with R. R on the left matches up with R on the right because it reflects onto itself. And then the Y on the left flips over to the O on the right. So there's our triangle congruent statement. So there's another example of ASA and HL. All right, on these you don't have to write the congruent statements. You're just saying which postulate. The postulates are the SSS, SAS, ASA, and HL. Says that the triangles are congruent. So the triangles on the left, on A, let's see, we've got a pair of congruent angles. We've got another pair of congruent angles, and then the side between the angles is also congruent. So we've got ASA. ASA. So by ASA, these two triangles are congruent. B, I got a pair of angles that are congruent. I got another pair of angles that are congruent. And look, I also have that side between the angles that is also congruent. So by ASA, these two triangles are also congruent by ASA. And then let's see what the last pair. The last pair, we've got a pair of angles that are congruent. We've got another pair of angles that are congruent. And we have a third pair of angles that are congruent, because remember, those are vertical, right? Write yourself a note so you can start kind of looking for vertical angles. So we've got three pairs of angles that are congruent, but unfortunately we don't have a postulate called AAA. So that's not enough information to say that these triangles are congruent. We'll talk more about AAA in the spring. These two triangles are actually similar, but they're not congruent. We're only talking about congruent triangles right now. So these two triangles are not congruent. One more example. Sorry, I lied. Two more examples. All right. So let's go ahead and look at example 7. It says, mark the drawing to show the given information and fill in the blanks. So sometimes you have to put the markings on your picture. So you need to be able to locate these segments and angles that they're talking about. 7 says E is the midpoint of KW. So E cuts KW right in the middle, which means its two halves, KE and EW, are congruent. It also says angle KEG, which is this guy, is congruent to angle WEH, which is this guy. So those two angles are congruent. It also says angle K is congruent to angle W. So those two angles are congruent. So what it looks like we've got is we've got angle, side, angle. Angle, side, angle. So by angle, side, angle, or ASA, these two triangles are congruent. So we're going to finish up this congruent statement. To me, it looks like these are being reflected over this imaginary line. So kind of use that transformation to help you write your congruent statement. K is going to reflect over to W. E reflects right onto itself. And then G reflects over to H. So there's that one. All right, the one on the right. This one, it's a little harder to see your triangles. Now, I do see those little triangles at the bottom, but I don't think that's what it's talking about. So whenever you see something like this is two triangles that are overlapping. I suggest you unoverlap them, if that's a word. You separate them. So this PFS is over here, and then this PRH is over here. So now when I label it, hopefully it's a little bit easier to see. So the first thing it says is FP is congruent to HP. Okay, so now it looks more like one of the pictures. If I was to label it on here, it would just make a big mess and I can't really see what's happening. We also know that angle F is congruent to angle H, which my angle H is not very good. Then you have to look for something special. So usually when you have overlapping triangles, a lot of times they share something. Right up here at the top, they share that angle P. So angle P on the left triangle is the same as angle P on the right triangle. So just remember, overlapping triangles usually share something in common. So now I can see my three things that are congruent: angle, side, angle, angle, side, angle. So by ASA, these two triangles are congruent. So let's complete the congruent statement. P goes with itself because they both share P. So to me, this is like a reflection. This is the line of reflection. Or when I separate it, it's kind of right here. F reflects over to H, or I could look at it this way. Okay, so F goes with H, and then S reflects over to R. S goes to R, and it looks like it's reflecting the other way. It's because it's kind of reflecting over, but then back on top of itself. So it kind of looks weird. But that's it. Bring your questions to class. Bring your questions to class next week, but do your very best on this assignment and let me know what questions you have. All right, take care.